Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. So this is the second part of the video for our tutorial. I will cover question number 7 up until question number 9. So if you haven't watched the previous video, please watch it first and please try to solve the question first, and then only you can watch this video. Okay, for question number 7, an electric conductor has a square cross-section with side 3 mm and its length is 15 meter. So you can imagine the conductor looks something like this. It's a square cross-section, so it's a weird looking conductor. It's not a wire, I think it's just a conductor. And it should look something like this. Okay, given the area is they give you the side, so 3 mm and 3 mm here, and the length is actually 15 meters, very long conductor. The resistance between the ends is 0.072. So they actually give you the values of resistance. And the first question, they want you to find the resistivity of the material. Okay. Question number B, they ask you to find the current flow, I, and if the length is decreased, explain what happened to the resistance of the conductor, what happened with the R, and what happened with the current. So now to solve this one, this one is pretty straightforward code. You can find the value of resistivity using the resistivity formula. Rho equals to RA over L. Okay, cuba biasakan tengok kamu punya formula sheet in front of the tutorial book, and then you can try to solve. 0.072. Okay, it will be 3 mm multiplied with 3 mm. So I change to meter. And then don't forget to take square, and then divided by the value of length, which is 15. So this is question A. And now you just have to press your calculator. Okay, the answer would be 4.32 times 10 negative 8. Okay, don't forget the unit would be ohm meter. Okay, if values for resistor, the unit would be ohm, tapi kalau resistivity, ohm meter. B, if power supply of 5 volt is applied between the two ends of the wire, so dia kata now dia actually is connected to a power supply which is 5 volt. Determine the current. Okay, if you want to determine the current flows in a conductor, you can use Ohm's law. V equals to IR. I can rearrange in terms of I got I equals to V over R. So it would be 5 divided by 0.072. Okay, kamu jangan bahagi dengan dia punya resistivity pula, bagi dengan resistance. Okay, and you should get 69.44 ampere. Question number C, if the length of the conductor is decreased, explain what will happen to the resistance in the conductor. So I can use the equation that I used in A. I can rearrange that one in terms of R. So R equals to rho L over A, assuming that L and A is constant. So rho and A is constant. So rho and A are constant. So what will happen when the length is decreased? When L decrease, in exam make sure you write full sentence. Jangan tunjuk arrow tu, jangan tunjuk lah. When L decrease, since R is directly proportional to L, then I can write R also decrease. Okay, this one you need to give a reason that R is directly proportional to L if the question asks you to explain. Kalau dia kata explain why, so you have to state lah. Okay, question D, I think I'm gonna write it over here. If the conductor is replaced with another conductor that has higher resistivity, explain what will happen to the current. So when you change the resistivity, you actually change the resistance. So I'm gonna write it here that R is directly proportional to rho. Okay, so now rho increase, R also increase. So you want to relate with the current, so I is directly proportional to 1 over R. They actually equals I equals to V over R, but since V is kept constant, so I write it over here, V constant. So if I have increase in resistor, that means my I will decrease. Again, make sure you try to write the relation if the question asks you. Okay, so this one, when the R is changing, normally R is constant, but this time R is changing. Okay, question number 8. Okay, for question number 8, they give you temperature at 20 degrees Celsius, so immediately you know that the question will ask you about change in resistance. So T0 is equals to 20 degrees Celsius. The resistor in the electric circuit connected to V is given 5 volt. Resistance is given as well. That one is initial resistor equals to 200 ohm. Okay, given that alpha is equals to 5 times 10 to the power of negative 3 per Celsius, the new resistance when the temperature of the carbon rises to 80 Celsius. Be careful with that word to or by. Kalau dia kata by, that one is delta T, but now state 2, so kalau 2 dia T je lah. Okay, again, check your formula sheet in front of your lecture notes and you get an equation. So it will be R equals to R0 1 plus alpha delta T. So R0 is 200. Okay, now you just have to substitute lah. Make sure you substitute correctly, press your calculator correctly, then you should be okay. 5 times 10 negative 3 multiply with the delta T, so it will be 80 minus 20. You don't have to change to Kelvin. If you want to change, it's up to you lah, because if you change to Kelvin, it's still minus with 273. Plus the alpha given here is in Celsius, so it makes sense if you want to calculate Celsius. So that one will be 60 multiply with 5 times 10 negative 3 plus 1 multiply with 200. Saja nak kamu dengar saya tekan calculator, so it will be 260 ohm. That one's for question A. Question B, the new current flow in the circuit. So dia tak suruh kira yang sebelum ni je pun, they just want you to calculate the new one. So again, use V equals to IR, we rearrange I equals to V over R. V is given, will be 5 divided by 260. So initially it is 200, but now it becomes 260. So resistance increase as the temperature increase. It makes sense. So it's logic. So I get 0.019. So if I change, maybe I can change to milli. Okay, for those yang still don't know how to use their calculator, if you want to change to milli, just press the ENG. Remove the decimal place and give answer in prefix. Okay, this one is ampere lah. It is actually milliampere. Okay, and then question number 9. Okay, question number 9, they actually give you internal resistor. You can see clearly dekat dalam soalan ni. Okay, the moment you see an internal resistor, for me personally, I would write this formula next to it so that I know I need to use this formula at some point so that saya tak terlupa yang ada involved dengan internal resistor. Okay, so this is the diagram given. So memang nampak obvious, this one is internal resistor, this one is external resistor. I can redraw the diagrams to something that you guys familiar, like this. Okay, this is the familiar. I change the form of parallel punya position tu. Saya still parallel, just that I redraw it. Okay, and then this is the V, still connected parallel to the parallel resistor. So basically the reading here would read the voltage terminal voltage lah. So basically if they ask you to calculate the voltmeter reading, it is actually ask you to calculate terminal voltage. Okay, calculate the voltmeter reading, that is the question. So you know the R1 equals to 4 and R2 equals to 6. Okay, apply to power supplies 12 volt, internal resistance 0.5. Okay, I can use first thing first, I would like to combine R1 and R2. Okay, when I combine R1 R2, I will get R12 over here. So if I got R12 there, so it becomes something that is more familiar to the one that you use to calculate. Okay, biasanya kamu kira macam ni kan, dan contoh example macam tu. So first thing first, I combine R12. So 1 over R12 equals to 1 over R1 plus 1 over R2. Okay, I just have to substitute everything. 4 and 6, sorry. So it will be 1 over R12 equals to 1 over 4 plus 1 over 6. Okay, and if you press your calculator, you should get 2.4. Okay, once you get this value, so this one is actually 2.4 ohm. You want to calculate the voltmeter reading, so you already have the R. So the next step, obviously you want to find the current that flow here. So if I have the current, then I can simply multiply with my resistor over here, then straight away I will get the answer, terminal voltage or the voltmeter reading. Okay, to find the current, I have to include the internal resistor. So these two is basically in series, so you know that you can use series punya R effective if you want to, or you can use this formula that I show initially. Maybe I want to use that formula. Dia sama je actually, formula tu derive from tu juga. EMF buruk lah. EMF is equals to I R plus R. Basically I want to find my I, so 12 R plus R would be 2.4 plus 0.5. I got there is 2.9, so it will be 12 divided by 2.9, which is 4.1. I run it off 4.14 ampere. Okay, once I got that number, I can plug back inside the equation of Ohm's law, V equals to IR, because basically I want to find the current, the voltmeter reading here, so across that particular resistor 1, 2. So just write it here, V12. This one is actually V terminal as well. Then again, tekan calculator. Okay, saya salah masuk. Betul lah. You just have to press your calculator and you should get 9.93 volt. Okay, so that one is for question A. Okay, for question number 9B. A toaster is rated at 600 watt. That one is the value of power. Connected to a 120 volt source. So that one is your V. Calculate the current that flows through the toaster. Okay, I know I told you guys I don't like this formula, but you don't have any choice here because this is the only information given, and the question want to find I. So I would be 600 divided by 120. So that one will be 5. Okay. Betul lah, 5 ampere. And then question number 2, they ask you to calculate the total resistance in the toaster. Okay, this time I can use my favorite formula. So it will be P equals to I squared R. Now I have the value of I. My R is equals to 600 divided by 25. Okay, I got 24 ohm here. Okay, so that's it for this part, this video. We continue to the next question on the next video. Thank you.